Okay, this should be the final lecture for artificial neural network. Actually, we try to discuss actually it's a kind of a tutorial. I just want to show you some example of hand calculation here. As you can see that again I'm using the example that we have discussed before, that we do some derivation on this one. Of course, when you do the hand calculation, you don't have to derive this equation anymore, because you can simply, if you know the formula, you can just put the numbers, and then based on the formula, then you can get the result there. Okay, you can read the first question there. Later you can refer to this slide I will upload in the e-learnings. Then you can see this slide there, and try to do some exercise there to do this one. Please do that. Okay, this is this example of the question there. After initialization during training session, W13, okay, this is W13 is equal 0.15. Just assume that during when you develop the code, okay, just imagine that when you develop code that represent this neural network, and during the training session means that you are doing a training, means that you are implementing the backpropagation for this neural network. The purpose is to find the optimum W, but during that training process, in the middle, at the middle process there, okay, after you initialize during the training session, okay, assume that you are using a random number to set your W there. So just assume when you apply the random's number, the W13 is equal 0.15. So how you get this one is a random number, is generated by the computer. Just assume that. Okay, W13 is equal 0.15, W23 is equal 0.2, 0.14 is equal 0.25, and so on. Okay, up until you will have as well as bias there. B3 and B4 is equal to 0.35, while B6 and B5 is equal to 0.6. So given a sample of training data whereby the x1 is equal to 0.01 and x2 is equal to 0.10, and this is the actual output, y1 is equal to 0.01 and y2 is equal to 0.99. So the equation is calculate the total error during forward pass. So what is meaning by total error? You need to remember that if you have two output like this, the total error should be, you need to total up between the error happen at the output 1 and error happen at the output 2. Then you need to total up, that is total error. But let's say if your architecture have only one output, so that's mean the total error should be only the error that happened at that output. Okay, so then again you need to do what you need to do. Then you need to label up everything's according to the given questions there, and then of course to get the error you need to implement the forward pass. Of course, even the question there asking about calculate the error, total error during the forward pass. So then you need to go from this side into these sides to calculate the errors there. It's a direct questions there. Okay, then you need to proceed at the first layer. You need to proceed at the hidden layer first. So based on the equation there, you can find the net 3 is equal to 0.335, and then from the net 3 you can obtain the O3. Forget to, yep, you need to also see in this question that assume the activation function f for each neuron is a sigmoid function. So that's why here you are just implementing the sigmoid function, then you can get the O3, and then you repeat the process again for to find the O4 there. I hope later you can try to calculate this one to check whether this answer is correct or not. Okay, you need to repeat this process again for to find the O4 there. And then after you find O3 and O4, of course you can proceed into output layers there. Then you just calculate, then you get the net 5, and then from the net 5 you get the O5, and then you need to repeat the same process to find the O6 there. So once to find the O6, and then of course the O5 and O6 over here should be your Y head 1 and Y head 2 there. Okay, if you check back the pictures there, okay, this is O5 here, this is O6 here, so means that Y1 should be equal to O5, Y2 head here should be equal to O6, so it's a direct there. Okay, so finally to find the total error, you need to calculate the E1 and E2. So of course E1 there is equal to this equation, okay, SSD, and then this one is, this value come from your hand calculation there, result from here 0.7514, and then this one is come from the question. Remember that this is actual Y1. Okay, actual Y1 is what is the actual Y1 is 0.01. Okay, so then you need to calculate, repeat the same process to calculate the E2. Once you get the E2, then you total up the error, then finally you get the total errors there. Okay, now that is finished for one question there. It's a very direct and it's not so difficult to do that. Okay, this is the second question. The second is also related to the question number 1 there. The second question is related to the first question. Okay, based on answer in the previous question, execute the backward pass and calculate all wake updater. Means that you need to calculate all the wake updater of W13, W23 up until W46. Yep, I'm sorry, this should be, this is also, this none should be, they have a triangles there. Yeah, there should be triangles. So calculate all the wake updater as well, the updater for the bias as well. Okay, one should be also have the triangles. Okay, and then once you find the updater, after that, okay, after that find the update or the new wake. Means that you need to calculate the new wake of the W13 up until W46, as well as B3, B4, B5 and B6. Means that once you find the updater, you need to update all the parameters here after executing the backward pass. And then the question also is here given this is the equation for the updater, and then this is the learning rate 0.5, and then in the question I also give you handicap there. Means that you don't have to remember this function. I already give in the question. Okay, but you need to learn how to derive from sigmoid. Okay, because if your f is equal to sigmoid, can you derive prove that the derivative of f is equal to f1 minus f there. So that is your homework there, because I believe that you learn this in your foundation or your matriculations. Okay, how to calculate this one? Okay, just remember again, this is what we find, what we get in the first question there. We get the total error should be equal to 0.29884 there. Again, if you talk about the backward pass, this is the pictures. Okay, and again the E5 and E6 there, the definition is this one. So this one I don't have to derive anymore, because we already do a lot of calculation to derive all of it. How actually the E5 and E6 equal to this one is from the long derivation there. So then because this is about backward pass, you need start at the output layer because it's going from this side into that side. Okay, so that is the how we compute. First you need to calculate the E5, and then from the E5 you know how to calculate the delta 5. Okay, delta 5 is equal to F apostrophe multiply with E5. This one, because this is sigmoid, then it becomes this one, and then so this one is equal to this one. If you talk about the neuron 5 there, and then okay, for O5 here you need to where you get the value for O5 is come from the first question when you calculate. If you remember that when you calculate there, the O5 you get, which is this one, yeah, 0.7514. so that's why in this question backward pass is depending on the forward pass, because many variables at the forward pass will be bring to the backward pass to calculate the updaters there. So O5 is equal to 0.7514. so that is where you obtain this one, 0.7514. okay, so if you calculate this one, this error E5 is come from here, then you calculate, then you get delta 5. Once you get the delta 5, then you can find the updater for W35 by using this equation, where the learning rate is have been given at the question 0.5. This one is come from the calculation here, and then the O3 is also come from the first question when you execute the forward pass. Okay, 0.3 is equal to O3 is equal to this one. O3 is equal to 0.5932. okay, 0.5932. then you get the updater for W35. Of course, to find the updater for W45, you need to repeat the same process again as this one. Okay, but you can see that for this one, because you already calculate here, then you just can use it. Okay, your delta 5 is equal to this one, 0.1385 multiply with 0.5 and multiply with O4. So how to get the O4? Of course, the O4 is also come from the first question there. The O4 is equal to 0.5969 here. And then you also do the same things for bias there, B5. B5 is just multiply between the learning rate there, 0.5, and your delta 5. Then you get the updater for B5. Okay, so then you need to repeat the same process, the same concept again for neuron or node number 6. Then you will get the updater for W36, W46, and bias number 6. And then we execute for hidden layer. Okay, we already finished the output layer. Then we do for the hidden layer. For hidden layer, the E3, just remember, if you talk about the simple ANN that we discussed in these pictures, okay, in these pictures, then the E3 should equal to this one multiply with this one plus this one multiply with this one. Okay, E4 is equal to this one multiply with this one, and this one multiply with this one. Okay, so that's how you calculate the E there. So that is the how actually that happened. Okay, it's this one have improved, and during the derivation, how actually we can end up in this kind of formula. Okay, you need to refer to the slide that we discussed a very long discussion on how to derive that. And then W35 is 0.4. Okay, then okay, you can see here, please do not update the W first. Let's find all the updater first before, and after you find all the updater, then you need to update all the W. You can see that's why I in the questions there, even I ask you to find all the updater first. Then once you find all the updater, after that then you update your W, because if you update earlier, then you might have make some careless mistake there, because when you want to find the updater for output layer, is not a problem. But when you want to find the updater for hidden layer here, if you update earlier this W35 and W45, then your E is wrong, because you are using the new W35 and W36 to calculate the E3. So that's why don't update don't update your wake before you can get all the updater of the whole neural networks. Okay, so that's why we use the old, or the initial W there, W35 is 0.56, which is not updated yet. This is the old W35 and this is the old W36. And then you multiply, and then you plus with the delta there, you will get the E3. Once you get the E3, from the E3 there, you can calculate the delta 3. So this one is the same process again. The formula is similar to the as the neuron in output layers. Then you key in all the you put in all the numbers there, then you get the delta 3 is equal to 0.0088. okay, and then at the end you find out that your W13 is equal to 0.0002, while your your updater of W23 is equal to 0.004. and then same goes to bias there. The updater for bias 3 is equal to 0.0044, and then you need to repeat the same process again for neuron or node number 4. Then you get the updater for W14 and the updater for W24 and the updater for bias 4. Okay, and then finally, that is how we do that. Okay, at the output layer, this is what you get. This is all the parameters for the updater related to the output layer, and then you can use the formula to update your W's there. So that's why in your new W's there, W35 is equal to 0.3560, and then the B5 there is equal to 0.5304, and then if you repeat the other parameter, then you will get the new W46 is equal to this, and W36 is equal to this, and W46 is equal to this. Okay, and then this is for the this is for W that involved at the hidden layer. Okay, the W13, the new W13 is this one, W14 is this one, W223 is this one, and W24 is this one. Okay.